Welcome everyone. To kick us off today, can you explain, how does geothermal energy actually work?
Geothermal energy works by tapping into heat stored deep inside the earth. The process has 4 key steps. Step 1. Deep wells are drilled to reach hot underground reservoirs where water is heated by the earth's internal heat. Step 2. Steam or hot water rises to the surface through the production well. Step 3. The steam drives turbines connected to a generator to produce electricity. And Step 4. The cooled water is re-injected underground to maintain reservoir pressure and keep the system sustainable. This continuous cycle makes geothermal a reliable and renewable energy source.
Are there different types of geothermal power systems, or do they all work the same way?
There are 4 distinct types. The first is the dry steam system, the simplest type, where natural steam from underground fractures is piped directly to turbines without any separator. The second is flash steam, the most common type today, where high-pressure hot water flashes instantly into steam as it reaches the surface, driving the turbines. The third is the binary cycle system, used where water temperatures are lower. The geothermal water heats a secondary fluid with a lower boiling point, which vaporizes and drives the turbines, making it suitable for more locations. And the fourth is enhanced geothermal systems, or EGS, engineered systems where water is injected into artificially fractured hot rock to extract heat where no natural geothermal fluids exist.
Where in the world is geothermal power being used, and how much electricity does it actually generate globally?
Geothermal power currently generates over 16,000 megawatts electrical, MW, worldwide. The United States is the largest producer with 3,827 MW, primarily from the geysers in California. Indonesia is second with 2,418 MW, followed by the Philippines at 1,225 MW. Kenya produces 712 MW, Mexico 970 MW, and Iceland 756 MW. In Europe, Turkey leads with 1,700 MW and Italy contributes 919 MW. New Zealand generates 1,005 MW and Japan 603 MW. Crucially, geothermal facilities are concentrated near tectonic plate boundaries and volcanic regions, where Earth's internal heat is closest to the surface.
Can you tell us more about the specific countries and regions that make the most use of geothermal power, and why?
All major geothermal users are in geologically active zones. The United States has the largest installed capacity, mainly in California and Nevada, where tectonic movement brings heat close to the surface. Iceland sits on the mid-Atlantic ridge, giving it extraordinarily rich geothermal resources. Heat supplies almost 90% of Icelandic homes and a significant share of its electricity. Indonesia and the Philippines sit on the Pacific Ring of Fire, the world's most volcanically active zone. Kenya benefits from the East African Rift Valley, where intense geothermal activity drives its Rift Valley fields. Other significant producers, Turkey, New Zealand, Italy, Mexico, and Japan, all sit near active tectonic boundaries. Only about 28 countries currently generate geothermal electricity, underlining just how location-dependent this resource is.
You keep mentioning that geothermal is location-dependent. Can you explain exactly why that is, and what it means for how widely this technology can be used?
Location dependence comes down to basic geology. For a geothermal plant to be economically viable, you need rock at least 150 degrees Celsius at a drillable depth. In most of the world, reaching those temperatures requires drilling 5 to 10 kilometers or more, currently too expensive. Near tectonic plate boundaries and volcanic regions, however, that heat is within 1 to 2 kilometers of the surface, making it accessible at a fraction of the cost. Iceland is the ideal example. Sitting on a plate boundary, it accesses cheap geothermal heat that warms almost 90% of its homes via district heating. Countries like the UK, far from active boundaries, cannot exploit high-temperature resources without very expensive deep drilling.
Since we are a UK-based audience, this is very relevant. Why exactly does the UK have such limited geothermal electricity, and is there anything the UK can do?
The UK's limited geothermal electricity comes down to geology. Unlike Iceland on an active plate boundary, the UK sits in the middle of the Eurasian plate, far from volcanic or tectonic activity. The geothermal gradient is low, meaning very deep, and very expensive. Drilling is needed to reach water hot enough for electricity generation. However, the UK does have options. Ground source heat pumps are widely used because shallow ground below 10 to 15 meters maintains a stable temperature of 10 to 15 degrees Celsius year-round, which pumps exploit efficiently for space heating and hot water. Some deep geothermal heating projects also exist, particularly in Cornwall, where granite intrusions generate extra heat, supplying district heating schemes. This is why most of the UK relies on heat pumps rather than geothermal power plants.
Beyond generating electricity, what other practical applications does geothermal energy have?
Geothermal energy has four main applications. First, electricity generation using high-temperature steam or hot water to drive turbines. Second, building heating and cooling. Ground source heat pumps use the stable shallow ground temperature to provide year-round heating and cooling, distributed via insulated pipe networks in district heating schemes, cutting energy bills and carbon emissions. Third, geothermal agriculture, using geothermal heat in greenhouses to extend growing seasons and in aquaculture to control water temperatures for fish growth. And fourth, tourism through natural hot springs. Geothermal baths attract visitors for relaxation and wellness in countries like Iceland, Japan, and New Zealand. Direct use applications are often more efficient than electricity generation, since no energy is lost in conversion.
To wrap up our lesson, can you summarize the key advantages of geothermal energy and also be honest about the challenges it faces? Thank you for joining this lesson today. This lesson is brought to you by tutorwarren.com, an innovative learning resources platform.